Good evening, everybody. This is me, Baburam Dawadi from Nepal. The topics of our article is recommendations for energy efficient SoDIP6 network deployment at the early stage rural ICT expansion of Nepal. This article is prepared in the context of Nepal to expand its ICT network infrastructures, focusing towards the green ICT by the implementations of software-defined network and the IPv6 network, commonly known as software-defined IPv6 network or SoDIP6 network. So this is the outline of my presentations. Now I would like to introduce with the scenarios of Nepal and its status. That is, we can see some of the glimpse that Nepal is still a least developed country and lies between the two big technology giants, India and China. ICT expansion at rural Nepal is quite challenging due to diverse demography and difficult geography, because the almost 80% land is covered by the hilly zones, so that the sustainability is the major issue for Nepalese service providers to expand services to rural zone. So we know that for the country's socio-economic development, access network, ICT, and the energy are the major three pillars. That is, road network, and then communications, and the power supplies. These are the basic needs for the country's development. But looking into the context of Nepal, we see that 80% households reside on rural Nepal, but unfortunately less than 1% households have access to the internet facility. Similarly, we can see there is only almost 10% fixed internet broadband penetrations, and then only almost 36% as a mobile broadband penetration. This shows that there is a tremendous opportunities for Nepalese service providers to expand the services throughout the country. But till date, the ISPs of Nepal are more urban-centric, city-centric. The good part is recently the government has initialized a big project utilizing its Rural Telecommunications Disbursement Fund, which is almost about 115 million US dollars, to expand the ICT infrastructure all over the country using all available media like fiber, wireless, and satellite communications. But unfortunately, still we go through the policy that there is a lack on green computing. That is a lack on the policy focus towards the green computing. So climate change impact is higher in Nepal, being a mountainous country. Expanding ICT infrastructure definitely increase the energy demand and increase CO2 emissions. Hence, considerations on energy efficient technology deployment is the most in the early stage network expansion in the context of Nepal. Existing legacy IP network lack smart management, and hence it has a greater energy waste problem. Definitely with this, the legacy IP network is complex in management and operation as compared with software defined IPv6 network. In this research, we present that software-defined and IPv6 network is more robust, new technologies with significant energy saving by its implementations, and we recommend to deploy those technologies while in the ICT network expansion for better sustainability of service providers in Nepal. So the major hypothesis of this study is that the SDN and IPv6 network has a significant energy saving as compared with the legacy network. That's why there is a significant amount of expenditure saving for the service providers if implemented with the SDN and IPv6 network in its network expansion. The current state-of-the-art review on ICT and energy consumptions and CO2 emissions shows that energy-efficient technology adoption plays a greater role towards green computing. CO2 emission can be reduced with effective management of legacy equipment like data center management. So similarly, making the network switches and links sleep in the idle mode has significant energy saving. That is, sleeping mode consumes only 20% of the energy, total energy. So ICT is a major contributions has a major contributions towards the CO2 emissions and energy consumption, because the literature shows that almost 10% of total world carbon footprint is produced by the ICT sector, estimated till the 2020. Similarly, the greenhouse gas emissions is contributed by ICT 1.3 gigaton by 2020. But the ICT can also be if we manage the ICT infrastructure properly, then there might have a significant saving of CO2 emissions and the energy consumptions due to the use of ICT sectors. So this in fact presents the ICT and its contributions in the energy and then CO2 emissions. SDN-enabled IPv6 network is flexible and can be controlled dynamically with different link capacity, leading to energy saving. But the major challenge of service providers worldwide is the migration or transformation of existing system into such flexible network for better efficiency and sustainability. So there are basically three categories of energy saving in ICT network. We apply smart saving in our experiment on this paper. Re-engineering concerns with the hardware optimizations and better fabrication of semiconductor technologies for energy optimizations. Then smart sleeping, make the device or link into sleep during idle situation. Similarly, dynamic adaptation provides the auto adaptation of traffic load and route management for energy optimization. So in our research, we provide the experimental analysis and its evaluations. We take the use case of university campus network, that is a Pulchok campus network for the evaluation of energy consumptions. The we applied smart sleeping and linear profile of energy consumption for network switches. The test bed used for this experimental analysis is the Mininet, the network emulator, and then Open Daylight controller. We also use the next programmable open flow controller and the kilowatt meter for energy consumption measurement. This is the IPv6 prefix used on this experimental test. So this is just the output of this topology created during the experimental results. It consists of 15 switches and 28 links. So we evaluate the results based on the use case from Pulchok campus network. That is, the network switches are basically Cisco ST300 series switches. So we assume that the switches consume in an average 80 watt for power, and then links consume 59 watt. Let's briefly go through the graph. Okay, let me point out with the laser. Yes, the left graph consists of shows the energy consumption by switches, and the right graph shows the energy consumption by the links. This is for the old system, that is a legacy IPv4 system, and the proposed system, that is software-defined IPv6 system. The red bar shows the energy consumption status by existing legacy IPv4 system, while green bar shows the energy consumption by SDN-enabled IPv6 network. So the graph shows the amount of energy saving with a linearly varying number of switches and links. So that if we see these both graphs of switches and links, the red bar indicates the higher energy consumption, that is for the old system, legacy IPv4 networking system, and then green bar indicates the energy consumption by software-defined IPv6 network. So by following the linear energy profile, we can see with the increasing number of switches or increasing number of links, definitely the energy consumptions by the system increase, and then we might have more energy saving with respect to the number of increase of the switches and links. So for the evaluations of the measurements of the energy consumptions, we see that the Pulcho campus departments are almost active from 6 a.m. to 8 p.m. That means the switches and links are active for 14 hours. Rest of the 10 hours, the network equipments and links are idle. That's why applying these smart sleeping for these 10 hours of periods, and considering the 700 switches and 2600 links in the SoDIP6 network as compared to legacy network, we can see the total energy saving of almost 473 megawatt, which is equivalent to 5,000 US dollar, taking 11 cents per unit charge of electricity. This is the standard average unit charge set by Nepal Electricity Authority. So with these evaluations, we can perform the similar kind of analysis for the ISP network also. That means ISP network can also go for such kinds of analysis based on their number of switches and links, and calculate for the total annual saving that helps for their annual operational expenditure estimation. Okay, in addition with the experimental evaluations, this slide presents the different approaches and practices for energy saving over SDN-enabled IPv6 network after its implementations. So the approaches practices are mainly categorized into three. These are optimization and placement, policy enforcement, and efficient monitoring. So these are all we present on behalf of our experimental results and then literature review. So instead of using separate physical server, running multiple systems and application over a single virtual machine is highly energy efficient. Okay, let's. So this is the network function virtualization and server virtualization is one of the area where we can have a better energy saving. Similarly, resource optimization based on network load demand, considering optimal design with careful attention for the base station management is another area where we can have energy saving and CO2 emission reductions. And the next is like the optimum management of the frequency, that is the spectrum planning is also the another area, and the proper placement of SDN controller with perfect load management for network devices would help to reduce energy consumption. It means placement of the SDN controllers and the associated switches in the network has a significant impact over the energy consumptions. Another category is the policy and deployment. In this part, we recommend government to encourage operators for latest network deployment. So enforcing energy evaluation and CO2 reduction parameters management through ICT policy will greatly contribute green ICT. Like for example, provide subsidy to use renewable technology to power the network devices. Service providers should conduct energy and performance assessment of equipment and services in their network once a year and declare the carbon footprint of their network operation. Similarly, regulator should come up with suitable policy and enforce operators to declare energy consumption and CO2 emissions periodically. While India and China government focus to green ICT, but Nepal government still doesn't have focus on policy initiatives. So in this regards, we put some policy recommendations towards green ICT. This part. Then the third category of energy saving include monitoring and proper management. Like energy management system is more suitable to data center network management and station management. Similarly, energy audit is another term used to measure the energy consumption, evaluation of the network equipment. So basically, in developing countries, network devices like switches are used even after the device life is expired. Those older devices consumes more energy and produce higher volume of CO2 than expected. Hence, timely settlement of such older equipment is also very important for the energy saving and then CO2 emission reductions. The energy benchmarking of network equipments simply means the energy audit. That means the operators may go for periodic auditing of their network equipments and measure the energy consumptions. That would be helpful for the prediction of the overall energy consumption of their networking equipments. So we comparatively study the Green ICT policy by India government, South Asian Telecommunication Regulators Council consultation documents, and China policy also. Based on those study, as I already discussed about some of the policy points, and these also are the some policy decisions to be incorporated over the ICT policy for the betterment of the country's network towards green ICT. So like power supply of rural telecom towers, BTS by hybrid energy supply systems. Hybrid in the sense the government may encourage for the electrical grid with the renewable technology like a solar system. Service providers should conduct energy and performance assessment of equipment and services in their network once a year. That is the yearly auditing of their network and then declare the carbon footprint of their network operations. Similarly, service providers may set the targets for the carbon emission reduction plan with the consequence year of the in the future. So with these presentations, I would like to conclude the paper that SDN enabled IBC network is more robust and energy efficient, has higher contribution towards green ICT. As we know that the service providers of developing nations, basically of Nepal, are lacking behind the network migrations because the SDN and then IPv6 network migration is in some stages if we see on the worldwide status. ISPs and telcos are also encouraged to migrate their network and then to deploy their network with the SDN enabled IPv6 network for the significant amount of energy saving that leads to their optimization in their OPEX, operational expenditure reductions. So we also recommend government of Nepal to incorporate green ICT in the telecom policies and harmonize it with the energy policy. That is, there is some discrepancies between energy policy and ICT policy. That's why to meet the target and proper implementation of the proper expansion of the network with the latest networking focusing towards green ICT, this is also required to harmonize. So these are the references, and this research is supported by Norwegian Institute of Science and Technology under its Energy and Petroleum program. We received some additional funding support from Nepal Academy of Science and Technology. Now I would like to thank you all for your patience listening to this presentation. Thank you.